8. Put a point on 8 and a point on 8 and connect those 2 points. Okay, this one would have a slope of what? Subtract x over. It's just -1 over 1, right? So to connect these 2 points, I would go down 1 over 1 every time, like that. All right. Now this one's less than. So do you see which region is going to be my shaded region? Because it's less than this one, which is below this line, but greater than this one, which is above this line. So it's going to turn out that this little region here is my one that's enclosed and shaded right there. Okay, what this means, and here's what you need to understand. Okay, this process is called linear programming. Okay, what we've done here is we've come up with inequalities that are all true here and graphed them. That means anything in this triangle, any points along the triangle or inside the shaded region are combinations of hours that can be chosen that will meet all these requirements. Okay, so for instance, if we choose this one right here, this 0.61, that means they could spend 6 hours doing simple and 1 hour doing a lab, and they will meet all the requirements that are needed here. They'll work less than 8 hours, but they'll make at least 40 vases. Okay, so anything along this triangle or inside of it are options here. Okay, but what we need to come up with now on number 8 is, if the glass blower makes a profit of $30 per hour working on the simple vases and $35 per hour working on elaborate, write a function for the total profit on the vases. Okay, the function is simply 30 times x plus 35 times y. Okay, this function has both x and y in it. Okay, we just got to come up with something that we're going to plug numbers into, because what's the ultimate goal here? The ultimate goal is to find the number of hours they should spend on each type to maximize the profit. They want to make the most money possible. Okay, and just so you know, the answer for the maximum amount will always be one of the vertices of the enclosed region. We don't have to test all of these points inside. All we have to do is test the points of the triangle. What are the points of the triangle? They are 5, 0, which by the way is not going to be the answer, right? Because another one's 8, 0. They're obviously going to make more money working for 8 hours than working for 5 hours. But the other one is 4, 4, right? We're going to plug in, well, if I plug in 5, 0, if they decide to go with the least amount of as possible and still meet the requirement, they could just work for 5 hours. They could make 8 of those simple vases each hour, and they'll get their 40 done, right? So they'll meet the minimum requirements, but they'll only make how much money? 30 times 5 is $150, right? $100. So if they have something going on and they can't work, they need to take off early or something, go into their kids' track meet or something like that, they could leave after 5 hours, work the whole day on simple vases, and they'll meet their minimum requirements, and they'll get $150 profit. But the other options are to just spend the whole day working on simple vases. Okay, they'll make $240 if they do that, or they could spend 4 hours on simple and 4 hours on elaborate. Remember, they get 30 an hour for simple, but they get 35 an hour for elaborate. What's 30 times 4 plus 35 times 4? 260. Okay, obviously they make more money with elaborate, so if they could, they would spend the whole day just working on elaborate, but you can do that because then they won't get the 40 vases done that they need. So this is the way they've got to do it. Okay, so the answer here is 4 hours simple and 4 hours elaborate. Okay, so the point of these problems is to come up with the inequalities. This is the toughest part of the problem, is coming up with these. Okay, once you come up with these, you got to graph them, find the points, plug them into your function, and that'll tell you the maximum amount of profit. So we're going to try one more of these now that we've got one under our belt here on the back. Okay, so on this one, it says a manufacturer makes 2 types of jumbo stuffed animals, both of which require time on 2 machines. The first type of animal requires 4 minutes on one machine and 3 minutes on the other. We couldn't say what the animal type was. It just says the first type. All right, so 4 minutes on one machine, 3 minutes on the other. Second type of animal requires 5 minutes on one machine and 6 minutes on the other. Each machine can be used a maximum of 180 minutes a day. The profit on the first type of animal is 8. Profit on the second type is 12. In order to maximize profit, how many of each type of animal should be produced each day? Okay, so when we're doing this, first thing to figure out is what are you going to call X and Y? Let's just call X animal 1 and Y animal 2 because it just says 2 types of animals. Okay. The maximizing equation, by the way, that's what we're going to do at the end. Okay, that's usually dealing with the money. Okay, so they're making $8 for each of these plus $12 for each of these. So I'm just going to write that there. Okay, but the toughest part, constraints, by the way, are the inequalities. All right, this is where we're going to come up with our inequalities that we're going to end up graphing down here. All right, so that we can figure out the maximum profit. Okay, so again, look at the information and see how many you can come up with. Thanks.
Yep.
All right, I'm going to call somebody. See if you have one of them for me. Okay. Got any of them yet? 30? Okay. How about 16? 29? 20? Okay. How about 18? Okay. Got one? All right. Okay, how about 23? Of course. They must spend at least 0 hours per, X stands for the types of animals. They must produce at least 0 of animal 1, right? Can't produce 0 or negative animals in a day. So X must be greater than or equal to 0. That's one of them. So, I wonder who's going to be called on next. But first, I will tell you, congratulations, you have completed participation requirements. Yes, we do. Now it's calling on number 5. They must produce at least 0 of animal 2. You're right. Okay, so almost always are you going to have x is greater than or equal to 0 or y is greater than or equal to 0, as long as whatever is being talked about does not make sense to be negative. All right? So just think about that as you're doing these. All right. Now we got to come up with the, so that just means, again, we're going to be bordered by, we're going to be in only this first quadrant here. Now we got to come up with our actual ones. So, got an idea yet? Oh, called on Luke again.
4x plus 3x plus 5y plus 6y is less than or equal to 180.
All right, so what you want to do is you want to kind of split that up. Okay, so you're putting, we don't want more than one x and more than one y in one. So you want to try it again or no?
7x.
No. Don't add them up either. I want you to come up with one. So we have two more to go. Okay, one of them should be dealing with machine 1. Okay, go ahead.
3x plus 5y is less than or equal to 180.
Now you're on the right track, but you didn't quite say it right. So now I'm going to try someone else. Think about what you look at it again, Luke, but in case you're called on again. How about 24? You want one?
7y.
There's not going to be a 7.
4x plus 3y is less than or equal to 180.
All right, as I look at this, that is actually not correct. Okay? Again, you're on the right track, but that one's not correct. I'll talk about why in a moment. Let's try 1.
3x plus 6y is less than or equal to 180.
Okay. That is one of them. Okay? Now, before I talk about that, let's figure out the other one. 14, want one? Go ahead.
4x plus 5x is less than or equal to 180. Oh, 5y.
All right. That would be another one. Okay, so one machine. So you can't put the 4 and the 3 within the same one, right? Because they kind of tricked you here. The first animal is this, okay? But the animal's the x's. So the 4 needs to be in one of them and the 3 needs to be in the other. So we're thinking of this sentence here. The 4 and the 5 are one of the machines and the 3 and the 6 are the other machine. They both can add up 180 or less. Those are our inequalities. Okay? All right. So now we need to graph these two. Okay? So remember, the easiest way to graph this, you could rearrange it to y equals, or you could just use the x and y intercept method, which is what I always prefer. Since they're both since these are like standard form, they're kind of easy to do that way. Just split up the equation. The x-intercept's 60 and the y-intercept's 30, right? 180 divided by 3 and 180 divided by 6. So if I go to graph 60 and 30, I've got a 60 right here and a 30 right here. Okay? I've decided I don't want to take time to graph it extremely accurately. I'm just going to go there. Okay. There we go. I'm going to draw the line. See what happens. Okay, let's do the other one. 4x equals 180, 5y equals 180. What's 180 divided by 4? 45. What's 180 divided by 5?
36.
Thank you. So one of them, so this one has an x-intercept of 45 and a y-intercept of 36, which is like right there. Okay, and now I'm going to connect those. both of these lines are less thans this time, right? So do you see where the shaded region is? It's the region that's below both of these lines. It's this one right here. Okay, so again, step 1, come up with the inequalities. That's what we did. Step 2, graph those lines. Okay, step 3 now is to state the points of this shaded region. Well, one of them's 0, 0. That's not going to be the answer. If they choose to make 0 of animal 1 and 0 of animal 2, they're going to make $0. Okay, that's not going to be the maximum profit. Another option is this point right here. That's 0.30. Another option is this point right here. That's 45.0. But the question is, what's that point there? We have to know what it is for sure. But I didn't graph it very accurately, so I don't know about you guys. If you have a good estimate as to